second. I never know when it starts. There we go. All right, so Unit 11, this is the last unit of geometry. What? Isn't that crazy? So with that, you have a Unit 10 test. The Unit 10 test is posted and open to you on OMHS. Haley, it's 33 questions. I knew you were going to ask. Beat you to it. At least for the regular. Yeah, kind of a weird number, right? All right, so your Unit 10 test, you'll see that on your plan on Friday. There is a review for you posted. How many are on the honors test? I didn't look at that one. I'm going to guess 40, Valeria, but don't quote me on that. All right, so Friday, I think 40. I don't know. I'm not looking at it right now. So Friday on your plan, you have the Unit 10 test. We're starting Unit 11 today, last unit of the quarter and last unit of the semester. I'm distracted by the chat. Hold on one second. Okay, so before we really get into Unit 11, I do want to show you something that's going to pop up on your plan starting next week. So starting on the 29th, you're going to see something on your plan called Delta Math. And there's 11 different little reviews in this website called Delta Math. Some of you saw the announcement on OMHS already this morning, and you did follow the directions on it perfectly. If you haven't, that's okay. Before the 29th, so before next week, you want to make sure that you look at that class announcement and create yourself a Delta Math account. So what it looks like, the announcement looks like this. And that one's for the honors, but the idea is the same. Okay, you're going to see an announcement on your, here's regular, on your plan. If you click on the link, that'll take you straight to it. You need to make sure you click register with email. Where's my pointer? And you need to make sure that you register with your VAW virtual account. If you're in my honors class, you probably already made an account when we did this in our small group. However, anyone who registered with Google, I had to delete you. So don't register with Google. Register with your email and use your VAW virtual. Any other emails I have to remove, okay? I haven't decided if I want to make this fair grade or not. I don't think I do. But you should definitely still do it. Maybe I'll do it for a completion. How's that? Yeah, it's a math review is what it is. So once you create your account, you're going to be logged into Delta Math, and it's going to look like this. And here it comes. It's not all that exciting, but what you have is different assignments, and I don't know why they're not in order. I don't know, but they're each titled. So this first one is like Delta number 5, right? I assign them to you in order. So just scroll down and find Delta Math number 1. Here it is. And so these problems are the problems that you're going to complete when you see it on your plan. Not very many. And when you click on one, it gives you a problem. And if you get stuck, you've got options here. You can watch a help video. You could see the solution, but you have to be careful because if you click see solution, it's going to tell you, are you sure? Because as soon as you click see solution, it's going to mark it wrong for you. You're not going to be able to get points for it. Or you could have it show you an example. So you could click show example. That doesn't do anything to the grade, and it'll show you a different problem. Okay. And then you can go back to the original problem. So you've got some options if you get stuck. Yeah, it's kind of like Khan Academy, Desmos, and iExcel just all mushed together. Okay, so and there aren't a whole lot of problems in each of those, right? Like this one is short. And so you'll see these appear on your plan. And what will happen is it'll say like Delta Math number 1. So that means that you would do the problems here in Delta number 1 practice. And then the next day when you see it on your plan, it'll say Delta Math number 2. And so you would have to find the one that says number 2. And again, I don't know why they're not in order. Here it is. Okay. You don't need to do any of them today. The only thing you need to do today is make sure you have an account with your VAW Virtual. Okay. Cool. All right. So you want to make sure you have that done by the 29th, because on March 29th is when you're going to start seeing these on your plan. Oh, you could definitely work ahead. Absolutely. Yep. If you wanted to work ahead, it's just so much fun. You want to do it all. Okay, that's fine. It's just I put it on the plan so that way it didn't feel like one giant assignment later. All right, let me go back to our thing. Here we are. How many questions is the SOL? The SOL is 60 questions. 50 of them count, and 10 of them are called field questions. So when will we finish this unit? This unit will be finished April 11th. Yeah, the questions on the SOL are random. Yeah, they don't give you like all of the slope questions and then all of the circle questions and then all the triangle questions. That would be cool. And this is the last unit of the semester, last unit of the course. So if you need a break during an SOL, all you have to do is raise your hand and ask for one, and your proctors can, take you to use the restroom if you need to, or let you take a drink if you bring a water bottle and leave it outside. Field questions are questions that they're looking to see if you learned it or not. So a lot of the times these questions feel extra difficult, maybe because I didn't teach you a topic because it wasn't one of our standards, but they want to see if you learned it anyway. It doesn't count towards your grade, whether you get it right or wrong. Yeah. Okay, good? All the questions? I think that's all of them. Yeah, maybe Navira. The code for Delta, Faith, if you look at our class announcements page, it's on there. Because it's different for regular and honors. Yeah. And if you are in my honors course, if you had an account and you notice that it's gone, it's probably because you used your Gmail account and I had to remove it. So just make sure you're using your VAW Virtual. All right, so that takes care of what you're going to be seeing on your plan for next week. Let's talk about what we need to learn today. Okay. Today we're going to be using the formula sheet. Well, you should be able to just see the announcement right on your announcements page there, Navira. If you can't see the announcement, send me an email and I'll send you the link to it. I want to go ahead and get started on the notes. I've given you the formula sheet lots of times, but just in case, I want to show you what it looks like. It looks like, where'd it go? This. If you need to find a copy of it, there's lots of places you can look. You can look in today's folder on OMHS. It's one of the very first things posted. You can look in the folder called Geometry Toolbox. You could Google Geometry Formula Sheet 2016. That's there too. And or you could email me and say, I really can't find this formula sheet. I also link it in all of the play posits. Yeah. Okay, so there's your formula sheet. We're going to use this today a lot. And know that you're allowed to use this formula sheet on an assessment. You don't have to memorize these. You're allowed to use it on quizzes, tests, exit tickets, and it's even linked into the SOL when you get there. Know that when you're using it on my assessments, it has to be a clean version. You can't come up here in the top and start writing other notes on the page and count and say, well, I'm just using my formula sheet. That doesn't count. It has to be completely unaltered version. Only thing on it is what's on it as soon as you download it. No extra notes, no extra formulas. Yep, Max, we're going to get there. That's why they're here. We'll probably that'll come later in the unit, not today. Yep. No, I'm excited for it too. Okay, we're going to start off kind of easy with those formulas. Do we have to bring them to the SOL? They won't let you bring it in with you. It's linked into the SOL, and I'll show you how to find it, Lydia. Yeah. All right, so here's the formulas that we're really going to use today, and we're going to find area. And what area actually is how much is inside of that two-dimensional shape. Do they give out a paper version too? I don't think they give out a paper version, Navira. I don't think so. I might be wrong, but I don't think they do. Okay, so you don't have to memorize any of these. These are all on your formula sheet. You just need to be able to figure out what shape am I looking at, find it on your formula sheet, and then find the formula that you need. So here we go. Okay. We're going to find the area of each plane figure. So how much stuff fits into that square? And I know it's a square because it has 4 right angles and the sides are congruent. So I look at my formula sheet. I'm going to be toggling a lot between things here. I look at my formula sheet and I find a square. Wait a minute, there's no square. Or is there? Remember, a square is a rectangle. So if I see a square, I could use the rectangle formula. Okay, so you don't have to memorize anything. Or you could know, oh, well, in a square, the length and the width are the same, which is why your formula looked like, where am I? This, where it said side squared, because your length and your width are the same. Either way, you can use that formula to find the area. Where did my pen go? Here we go. Yep, so your area is length times width, or just side squared, same thing. So that's where you type in your calculator, 8.5 times 8.5, and you get 72.25. Now we just need to talk about the units for a minute. This was feet and this was feet, and I just took feet times feet, which means my units will be feet squared. Okay. Anytime you're finding the area, your units will be square units. So in number 1, the area units are square feet or feet squared. They're the same thing. I can tell you that sometimes it's very difficult to type feet squared, just whatever program is being used. So it might be written like this, square feet. It means the same thing. So if you see feet squared or square feet, that's the same thing. On your assessments, your units will be taken care of for you, just so you know. Okay, let's look at number 2. I'm going to do one more with you and then let's set you free to do the other 4. Number 2, we have a triangle. So we look at our formula sheet, we find the triangle, and the area of a triangle says 1/2 base times height. Now here's something that I really want to kind of bring to your attention. Your height, it will always be perpendicular to the base. So you look for your right angle, and that right angle, the 2 segments that make it are your height and your base. Whether that triangle is quote unquote upside down or sideways, okay? My height doesn't change whether I stand up or lie on the floor, right? I can say, oh, I'm 5'3", and then I lay on the floor. Well, I'm still 5'3", whether my height is here or here, okay? So just be very careful. Some students will see a triangle like this and they're perfectly fine finding the height, but as soon as that triangle gets turned sideways, they get stuck. So just remember that your height is perpendicular to your base, and that's true for triangles, parallelograms, trapezoids, all of it. Hold on a second. Navira, I'll answer that after I'm done with these examples, okay? So here in number 2, we have the segment inside the triangle that is perpendicular to this side. So that means that the base will be 15 and the height is 21.3. So the area of your triangle, 1/2 base times height, is 1/2 times 15 times 21.3. Type that in your calculator. 159.75 meters squared. Easy peasy. Just taking our numbers and plug them into the formulas. You don't even have to memorize the formulas. All right. I want you to look at your formula sheet. Hopefully you have it nearby. You can open up in another tab or something if you need to. And find the area of the last 4 on this page. Okay, let's take, I don't know, 5 or so minutes. Okay. You're welcome to use the formulas that were on the first page of the notes. You're welcome to use your formula sheet. You're welcome to go into OMHS and open the formula sheet. And then once you finish those 4, because I'm always so excited to explain them, go ahead and give me a check mark so that I know that you are done. Okay, once you have found the area of numbers 3, 4, 5, and 6, give me a check mark so that I know I can move on. You don't have to type your answers in the chat. That would be a lot of answers in the chat. All right, so when you're done, go ahead and give me a green check so I know that you're ready. And I'm going through and I'm asking for people to put their answers on the board. So if you have a private message from me, you have whiteboard privileges. I told you which one I'd love for you to put on the board. Navira, I'm giving you whiteboard privileges. 1 second. Where'd you go? There you are. All right, awesome. So I've asked 4 of you to put your answers on the board, and I told you which one. Thank you so much, Faith. Beautiful. Number 5. Yes, Heather, you're great. Perfect. My number 3 person isn't responding to me. Let's see who else is here. All right, thank you, Nishmiya. I'm going to give you privileges in 1 second. Where are you? Where are you? There you are. There you go. Vera, I'm fixing yours for you. Okay. Thank you for trying and doing it. And just see what I put there. How this got there so many times. Awesome. All right. So the answers on the board are correct. You can go ahead and check them. Thank you for those of you who put them up here on the board. You are awesome. Gold stars for all of you. You rock. All right. So number 3, we had a parallelogram. And in that parallelogram, we had to find its area. So you look at your formula sheet and you find the formula for area, which is just length times width, or base times height. I guess it says base times height. Remember, the height is perpendicular to the base. So the height here is 7.1 and your base is 12.9. For number 4, you had a circle. So you looked at the circle and you found the equation for area. And so the area of a circle, which we've already done back when we in our circles unit, but it was pi r squared. And I know that's not fun to type, so this is perfectly fine. I think this S is supposed to be a 2, which is fine. 530.93 yards squared. Number 5, we have a trapezoid. It's not an isosceles trapezoid, but it's still a trapezoid. The height of that trapezoid is perpendicular to the base, so the height was 16. They were trying to trick you here. They were trying to get you to say that the height was 16.5. No, no, no. The height has to be perpendicular to the base. So the height is 16, and a trapezoid has 2 bases. The top here is 19, and the bottom base is 27. So your equation is 1/2 times the height times the base plus base. Oh, Max, did you get the same answer? Just out of curiosity. Might be a rounding thing. So Max says, I saw a triangle and a trapezoid, and so he did that instead. You should have gotten the same answer. It could have just been part of rounding maybe. But if you found the area of the triangle and then you found the area of this trapezoid, and then added them together, you should have gotten the same answer. Yeah. Oh, yeah, don't do 27 divided by 2. Here, all right, I want to talk about this because this is fun. So let's just look at this trapezoid for a second and pretend that you saw it as a triangle and a smaller trapezoid. Okay. If you wanted to find the area of that triangle, you know its height is 16. So my notation here says area of triangle, 1/2. You need to find this length. Well, if this length is 19, oh, you would have had to know this length, and we don't. Darn, that could have worked. They didn't tell us this length here. If they had told us this length, you would have subtracted it from 27 to give you that base. So this isn't actually going to work in this case. You can't do 27 divided by 2 because that 27 isn't being split into 2 equal parts. Almost worked. Yeah, you would have had to use the trapezoid here. Well, 27 minus 19 would be if you included that whole thing. This isn't 19. If this had been a rectangle here, it would have been, but because this piece right here is not congruent to this piece. They're not the same. If it had been a rectangle or a square, you could have done that. And then in number 6, we have a rectangle. So you have to find the area of a rectangle. And just be very careful. The person who originally put her answer up here was just trying to see if we were paying attention. And she first wrote this. What was wrong with this? There was something not quite correct. That's the perimeter. Yeah, it's okay. It's perfectly fine. Make your mistakes now. I want you to make the mistakes so we can learn from them. Because I guarantee you, you are not the only one. Okay, so just be very careful. A good little lesson in making sure that you're using the correct formula, because that formula sheet is full of formulas. You got to make sure you're using the right one. Nice. All right, now the ones on the next page are still more practice with formulas. They try to get a little tricky on us here. They do. We're not going to let them trick us, though. Let's all look at number 7. Okay, looking at number 7, we have a triangle. And the area of a triangle is 1/2 base times height. I'm going to give everyone whiteboard privileges. I'd like you to take your pointer tool and point to the height. Yeah. All those pretty colorful arrows. Wonderful one. Yes. All right. Thank you, guys. You rock. The height is exactly what everyone's pointing to there. Oh, we got 2 arrows stuck. Oh, I know. If you were one of my people who wrote on the board, go ahead and click off your arrow. Thank you. All right. So the height there is 14. In your obtuse triangles, your height is going to be on the outside. Okay. The height is allowed to be on the outside. That's okay. So the height here is 14. If it helps you to write what each of those variables equals off to the side, be my guest. All right. Now, one more time, you're going to point to the base. What is the base of this triangle? Yeah. Perfect. You guys are awesome. I didn't trick you. All right. The base is 29.5. But what we are actually finding the area of is this triangle. Ah, maybe if I can draw a line. So this is the triangle that we're finding the area of. It just so happens that its height is outside because the height has to be perpendicular to the base. So then we just plug those numbers into our formula. 1/2 times the base times the height, and we get a number. We get 206.5. And our units are squared. So square inches, inches squared, same thing. That might happen in our parallelogram too. Ooh. Why couldn't 37.2 be the base? Very good question. Let me erase some of my writing here. Remember that your height has to be perpendicular to the base. There's no hypotenuse here because it's not really a right triangle, right? This is the triangle we're finding the area of. But this height or anything, there's nothing that's perpendicular to that side. There's no segment there showing me that it's perpendicular. So when you're looking for your height and your base, you have to look for what is perpendicular to what. So even though the height isn't intersecting the base over here, it's still perpendicular to it. Okay, so yeah, that was a really good question. So many people are going to make that mistake. I hope they're listening to me so they don't make it again. Your height has to be perpendicular to the base. So look for your right angle, even if it's not inside the triangle. The height and the base have to be perpendicular. So that 37.2 was there to throw you off and make you use the wrong number. Really good question. All right, let's look at number 8. Let's play this point to it again game. In number 8, what's the base? Where's the base in number 8? Very good. You could point to one other place. Where else could you have pointed? Yeah, you guys are awesome. You're right. All right, so the base in number 8 is 11.8. Can you point to the height? Yeah, very good. Very nice. Thank you. Okay, so that 30, I want to go back to number 7 because some questions are still popping in on number 37. There is not actually a right triangle that I'm finding the area of here. Okay, the triangle that we're finding the area of was this triangle. This is not a right triangle. Okay, this dotted line out here is just to show you what its height is. We did not find the area of this triangle. That's not what we found the area of. We found the area of this green triangle, and that black dotted line out there was only to show us the height. That's it. If it had been a right triangle, then yes, that 37.2 would have been the hypotenuse. But it's not a right triangle, so just be very careful. We found the area of this obtuse green triangle. That's what we found the area of. That black dotted line there was just to show the height. Just like over here in this parallelogram that we were just talking about, we are going to be finding the area, how many square meters would be able to fit inside this parallelogram. This dotted line out here is added to show us what the height is. So the height is 16.1. Honestly, they could have put that dashed line here. Right? These are parallel lines, and that's still 16.1. They could have put the dashed line here and done that and said 16.1. They just chose to put it on the outside in this picture. Okay, so that was the height. The base is 11.8. So there was one number there to throw you off, that 18.5. Okay. They're trying to trick you and get you to say that 18.5 is the height. It's not. The height has to be perpendicular to the base. So you look for your right angle and you now know the height. This 18.5 could come in handy later if they ask us to find the perimeter, right? Because then we could say, oh, 11.8 plus 18.5 plus 11.8 plus 18.5, and that would help us with the perimeter, but it's not helpful with that area. So the area of the parallelogram on your formula sheet says base times height. Kind of like a rectangle, right? But just a slanty rectangle, maybe. Where are we? So we're just going to say 16.1 times 11.8. Hey, calculator, what's this? Okay, and we get 189.98. The directions on your assessments will tell you how far to round. I like to go to the nearest hundredths. Number 9. Yeah, Naveera, you got yeah, you got it. Let's look at number 9. Number 9 is this shape that is not on our formula sheet. But what shape on our formula sheet might help us? Yeah. The circle or the Urkel, as Nishmiya says. So we're going to find the area of the circle. Perfect. Let's find the area of a circle. Pi r squared. Okay, but this isn't a circle. This is half a circle. So the area of half a circle will be half the area of a circle. Yeah, you guys in the chat, you rock. You figured me out. Okay, so if you see a shape that you're finding the area of, but you don't actually have that formula on your formula sheet, see if it can relate to any of the formulas that are already there. For this one, it's a circle. So we'll say, okay, area of our circle is pi times the radius. Radius is 17 squared. And then we can take that answer and divide it by 2. Make sure you round your answer on the very, very last step. Yep, perfect. 453.96 square feet or feet squared. Make sure you use the pi button on your calculator. That'll give you the most exact answer. All right, let's look at number 10. Remember that the height has to be perpendicular to the base. Okay. In number 10, can you point to the height? I disagree with quite a few of you. All right, I'm going to do something here real quick. Turning off your tools. Where's my snipping tool? Hold on one second. All right, I'm just taking a snip of the picture, so it might look weird when I paste it in here. Hold on, let me get rid of this feet squared. That's messing it up. Okay, let me try again. Thinking about where is the height of this thing? There we go, that's better. Copy. There it is. All right, what if I took this trapezoid? I did this. Now, can you point to the height? Yeah. Very good. It's not 13, it's 5. It's not 7, it's 5. So let's talk about a trapezoid for a second. Okay, so in our trapezoid, a trapezoid has bases, right? And we call the top here base 1, and we call the bottom base 2. The segment that is perpendicular to the bases, that's the height, even if it's sideways. Okay, so even if it's sideways, the height is perpendicular to the bases. Whoa, okay, I'm not quite sure what's going on there. There we go. So in your trapezoid, the bases were here. It was a sideways trapezoid. So the height is perpendicular to the bases. So your height here is 5. If that tricked you the first time you saw it, hopefully it won't trick you now in the future. Your bases, so I'm going to say base 1 is 7 and base 2 is 13. And now we have everything we need to find the area. The area for a trapezoid is 1/2 times the height, that was 5, times the sum of the bases, 7 plus 13. So you do 7 plus 13 is 20, times 5 is 100, half of 100 is 50. Yeah. Units are millimeters squared. All right, cool. How are we doing? We're doing good on time here. All right, let's look at the next slide. What happens if we're missing a piece? Well, there's always going to be enough information in the picture for you to figure out the missing piece. It's like a puzzle, right? So if you don't have it, look at the big picture and say, what else do I know to help me find the missing piece? So in number 11, the triangle, I know the base is 7. So I can say, okay, the base is 7. Don't know the height. Yep, you in the chat are all right. Man, Pythagoras likes to come back to visit us, doesn't he? Let's call the height. You could call it h if you wanted. I get very hesitant in calling it h because I don't want you to think hypotenuse, right? That's usually what h has been up until this point. So I'm just going to call it x. So the hypotenuse is 18.2. One leg is 7. The other leg is what we're missing. And we're solving for x. So what do we get? We get 16.8. Hopefully you don't need to see me go through all of the steps on this Pythagorean theorem again. But if you want to see it, it's on the key on OMHS. So our height is 16.8. All right, now we have everything we need. The area is 1/2 base times height. Okay, so we get 58.8. If you're looking at your key, at the key that I posted on OMHS, and you're looking at your answer, and they're off by a couple decimal places here, like maybe you got 15.6, 58.6 or something. What I did when I created my key and I make my answers is I don't round until the very, very last step. So when I had the 16.8 on my calculator, I didn't round it. I actually had, well, let me put it in 18.2 squared minus 7 squared. I had 284.24, and then I took the square root. 16.8 was exact. So that should actually work out. But there will be times where you might have had to round on this step. I didn't use the rounded number. I used the exact answer in my answer. So if yours is off by a couple decimal places, that's why. All right. Let's see. Let's look at number 12 here real quick. Which would be right on a test? It would account for that on the test. It would either be multiple choice, and you'd have to pick the one that was like super close to yours, or it would accept the rounded, the one with rounding, and the exact one. Yeah. Let's look at number 12. Number 12 is missing the height. Bum, bum, bum. What are we going to do? No height. Wow, that was a terrible line. Let me try that again. Cool. There's the height, but we don't know it. Okay. We know the bases. Base 1 is 19 and base 2 is 7. So let's find that height. Okay, so we need to look at our right triangle. Here it is. We don't know the height. That's what we're looking for. We know the hypotenuse is 10. What's the length of this? Well, let's put in the other height here. Okay, well, what I now see is this piece is 7, right? It has to be congruent to this piece. And this whole thing is 19. So I'm going to say 19 minus 7, that's 12. So between here and here, they have to add up to 12, and they have to be the same. So 12 divided by 2 is 6. So each of these pieces is 6, which means this leg is 6. Here's our Pythagorean theorem again. Hypotenuse squared, leg squared plus leg squared. What do we get? We get 8. Look at that Pythagorean theorem. Pythagoras just likes to come back and haunt us, huh? All right, so the area of a trapezoid is 1/2. The height is 8, and the bases are 19 and 7. So I'm just plugging the numbers into the formula. 19 plus 7 times 8 times 1/2, 104. Our units are centimeters squared. All right, before we move on, I want to give you your attendance quiz word. Your attendance quiz word is height. Write that down somewhere. Height. You got it, Navira. Height. That's weird, Nishmia. I wonder if I put the date in weird. I don't know. I'll go in and double check that. Don't worry about it though. You're all right. Yeah. All right, let's look at the last set of questions. Well, there's 2 sets, but these are all application word problem type questions. When you start seeing words, don't get scared. It's just, the math in words. It's not a big deal. Let's look at for keywords like triangle, right? We have a triangle with an area. Oh, I know the area of a triangle is 1/2 base times height. Has an area of 45.5 centimeters squared. Oh, that's the area. And a base that measures 14. Oh, the base is 14. Find the height. Okay, we can find the height, right? 1/2 of 14 is 7. Divide both sides by 7. What do we get? 6.5. So this is the height, not an area, it's the height. So your units are just centimeters. Okay, so for most of these here, what they're going to do is they're going to tell you the area. They're going to tell you a little bit more about that shape, and then you have to find one of the missing dimensions. Maybe you find a missing height, a missing base, a missing diameter. Okay, whatever is in that formula that they didn't tell you, we're going to solve for. So let's see. Let's look at number 15. A trapezoid with base measures of 23 and 29. If it helps you to draw a picture, you totally could. But I'm just going to call it base 1 is 23 and base 2 is 29. And it has an area of 390 kilometers squared. Find the height. Okay. So the area of a trapezoid is 1/2 height times base 1 plus base 2. Well, the area is 390. The height is what we're solving for. And the bases are 23 and 29. So I definitely wrote too big. 23 plus 29 is 52. I multiplied both sides by 2 to get rid of that 1/2. You could have just taken 1/2 of 52. That would have been okay too. So we get h times 52 is 780. because I multiplied both sides by 2 to get rid of that 1/2, and then divide both sides by 52. So the height of this guy is 15, and it's just a height, so its units are kilometers, not kilometers squared. The only calculation that has square units is area. Okay, there's a few more examples where you have to solve for a missing dimension. I'll leave number 14 and 16 for you. I want to look at number 18. Number 18 says find the perimeter of a square with an area of 361 square feet. So they're giving us the area, and we need to find the perimeter. So I'm just going to go ahead and sketch with a square here. Its area is 361 square feet. I want to know the perimeter. Well, I could find the length of a side. If the area is side squared, right, and the area is 361, well, then I could find the side, square root. The square root of 361 is 19. So this tells me that each side of this square is 19 feet. And now that I know the length of each side, you can say, oh, well, 19 times 4. And 19 times 4 is 76. So the perimeter is 76 feet. Perfect, Navira. I really liked how you typed that. All right, and then we're going to do this application. Okay. Mr. Peyton would like to paint his deck. The dimensions of the deck are in this picture. He's got a beautiful trapezoid-shaped deck. 1 can of paint covers 72 square feet. He wants to give it 2 coats of paint. How many cans are we going to need? Right, well, what do I need to calculate if I want to know how much paint for even just 1 coat? Do I want the perimeter? Do I want the area? Yeah. Look at all of the areas popping in. Let's find the area of this trapezoid. And we're lucky they gave us all the things that we needed. The area of a trapezoid is 1/2 times the height. The height here is 16.5 times the sum of the bases. The top base is 14 and the bottom base is 24. So we type these into our calculator and calculate the area, and we get 313.5 feet squared. All right, so that's the area of this deck. Now let's look at the cans of paint. If we needed 2 coats of paint, that means I need to paint this 313.5 feet twice. So 2 coats would have to be 627 feet squared, because that's painting that area 2 times. So if I want to paint a total area of 627 feet squared, and each can of paint covers 72, how many 72s go into 627? About 8.7. So we're going to need 9 cans of paint. We'll have a little bit left over. I don't know, maybe he can paint the stairs that go to the deck too. I don't know. Awesome. Yeah, maybe, Navira. I don't know. All right, that brings us to the end of today's lesson. Okay, there's an exit ticket for you. Now, I've been told that the exit ticket is already showing up as overdue, and I'm not quite sure why. Don't worry, it's not overdue. After I'm done teaching my lessons today, I'll go in and fix that. I probably put today's date as it being due instead of tomorrow's, which is just a mistake on my part. My bad. Sorry, guys. I'll fix it. You're fine. Just as long as you do it, you're fine. And then don't forget to do the attendance quiz. And if you have any questions, you are welcome to email me. And I'll be in office hours on Tuesday at noon. All right, everyone. Have an awesome day.